Today's lesson is on the rational zero theorem. This theorem applies to polynomials. So what I did here is just wrote, this is a very mathy way to write a generic form of a polynomial. And really it's just showing the exponents are going in decreasing order. Then it goes down to 2, 1, and then a constant. And that these are leading coefficients. That's all it is. Okay. So the rational zero theorem, we're going to look at the leading coefficient and the constant at the end. I'm going to call the constant at the end P, and then the leading coefficient Q. So the rational zero theorem is going to give us all the possible rational roots. So remember when I say roots, those are your x-intercepts. Those are your solutions when the polynomial is equal to 0. Okay, so to find all the possible rational roots, what we're going to do are this quotient P, and it's not just P divided by Q, but what it is we're going to list all of the factors of P and divide it by all the possible factors of Q. So just reminding, the constant would be the numerator, factors of the constant is the numerator, and factors of the leading coefficient is the denominator. Okay, so here's an example. So we've got this polynomial function, and we want to look at the constant we're going to call P, and the leading coefficient this time is just 1. We're going to call Q. So all of the possible roots of this polynomial are going to be in this form, factors of P divided by factors of Q. So let's start by writing factors of P, factors of 30. So plus and minus 1, plus and minus 2, plus and minus 3, got 5, 6, 10, 15, and 30. So those are all the factors of P. Factors of Q, well, that's just 1. That's just plus and minus 1. So now all of the possible roots would be dividing each of these by 1. Well, dividing by 1 doesn't actually change anything. So really, I don't need that dividing by 1, and it's just these numbers. So what that means is this set right here, they're not all going to be roots or zeros of the polynomial function, but all of the rational roots that it does have are somewhere hidden in this list. Just a reminder that roots, those are x-intercepts. So that would be an x value and y is 0. So there are a few different ways we can do this. So we can just plug in these numbers in for x and figure out which ones give you 0. You can do synthetic division and divide and see which one gives you a remainder of 0. But what we are going to do is actually use our graphing calculators. Okay, so I input the polynomial into my y equals, and I graphed it. I already kind of messed around with the windows to get it to fit. So you can see here that it's going to cross twice. So 2 of these list of numbers are the real zeros. And really, this is a really nice graph. You can see exactly where it crosses. But I'm going to go to the table because you can't always tell exactly where. Okay, so second graph, I'm going to look at the table, and I'm going to start inputting these possible zeros from my P over Q ratio. So I'm plugging in 1, -1, 2, oh, 2, there's a 0, -2, 3, -3, and just start plugging them all in until you get there. Because from the graph I knew it crossed twice, so I can just stop right there once I get my 2 zeros. So my zeros, x equals 2 and x equals -5. So the ratio just gives you all the possibilities, and then you have to test it to see which ones are the actual zeros. Okay, let's do this process one more time. So let's list all the factors of P and all the factors of Q. Okay, so P, I've got factors of 8, plus or minus 1, 2, 4, and 8. And now we have a leading coefficient greater than 1. So factors of 3 are 1 and 3. So what this means, if you're going to list out all the factors, 1 divided by 1 is 1. But now I also have 1 divided by 3. And then 2 divided by 1 and 2 divided by 3. 4 divided by 1 and 4 divided by 3. And then 8 divided by 1 and 8 divided by 3. So I am perfectly fine if you really just leave your answer like that and you understand that this means all of these possibilities. All right, so now pause the video, get out your graphing calculator, and I want you to try plugging these in and figure out which ones give you a 0. So I plugged it into y equals. My graph tells me I'll have 3 of them that will work. And I started plugging them in and I got 3 zeros. As you can see, 1/3, -2, and 4. So I knew it graphed 3 times, or across the x-axis 3 times, and I started just plugging in all the possible rational zeros until I got 3 of them. So x equals 1/3 and -2 and +4. Now we're going to use the idea of listing all the possible rational zeros to factor and solve a polynomial. So here we have this polynomial, and I'm going to look at factors of P over factors of Q. So I kept the numbers nice and small for this one. So factors of 2, it's just 1 and 2. And then factors of 1, so my only options are 1, plus and minus 1, and plus and minus 2. So on my calculator, I input my function, and I plugged in the very first possible 0, which is just 1, and it worked out. It's a 0. So what I'm going to do is do synthetic division and divide my polynomial by 1. So coefficients 1, -5, 9, -7, and 2. I didn't give myself a lot of space there, but that's okay. So bring down 1, 1, -4, -4, 5, 5, -2, -2, 0. So that also confirms it's a 0. So what I'm going to do now is think of this as factoring. So if there's a 0 at 1, that means x minus 1. When I divided by x minus 1, I got this, which is x to the 3rd minus 4x squared plus 5x minus 2. Now if I go back to my table, and so I found the 1. When I plugged in -1, didn't work. When I plug in 2, it does work. So I'm going to divide by 2. But I don't need to divide the original one. I can divide this, because this will also have a factor, a root of 2. So synthetic division, I've got 2, and I'm going to do these coefficients, 1, -4, 5, and -2. Okay, so 1, 2, -2, -4, 2, 0. So there's my remainder of 0. That's good. All right, so now I have this original x minus 1. If 2 is also a root, that's x minus 2. And then I have this left over, which is x squared minus 2x plus 1. Now I know how to, I know how to factor this. So the original x minus 1, x minus 2, and then factoring that, that is x minus 1, x minus 1. So this could be the final factored form, or you could also change it to x minus 1 cubed times x minus 2, which means its zeros are x equals 1 with a multiplicity of 3 and x equals 2. So to recap, I found all the possible zeros. I plugged them into my XY table, found one, divided, found another, divided, and kept breaking it down until it was fully factored and solved. Okay, so we're going to do that one more time. So last part of the video, your choice, either just kind of watch along as I quickly go through this, or you could pause the video and try to go through the process on your own and come back and check. So here are my factors of P over Q, and if Q is just plus or minus 1, I don't need that. So there's all the possible zeros. On my calculator, I plugged this in, and I started plugging these in my table, and I right away found that 1 is a 0. So I'm using synthetic division to divide by 1. So 1, 1, negative 8, negative 8, 21, 21, negative 18, negative 18, there's my 0. So to write this, what I've factored so far, a 1 means x minus 1, and then this is x to the 4th minus 8x to the 3rd plus 21x minus 18. If I go back to my calculator, I'm going to type in, let's see, negative 1, I get 96. When I plug in 2, I get 0. So there's another 0. So I'm going to divide what's left here by the other 0, by 2. So coefficients, 1, negative 8, 21, negative 18. 1, 2, negative 6, negative 12, 9, 18, 0. So now let's write it in factored form what we have so far. We've got the first one that we divided, x minus 1. We have the second one, x minus 2. And we're left with x squared minus 6x plus 9. So we factor that, x minus 1 times x minus 2 times, this would be x minus 3 times x minus 3, or x minus 3 squared. So there is factored form. So my solutions, x equals 1, x equals 2, and x equals 3 with a multiplicity of 2. So there's your full video on possible rational zeros and then using them to fully factor and solve polynomials. Good luck.